car was jam-packed of everything I owned. Guitars, music, every piece of clothing I owned. So my car is full of all my, what?
No, it's just, your picture's cute, but like,
yeah, you look like.
It looks like you're photoshopped.
No, it's real. That's a real picture, I promise.
You talk like a nice happy couple.
Yeah.
Well, you're always
You know what I always say? If you can fake it, that's half the battle. So my car was jam-packed with everything I owned, and I pulled off the highway at Victoria Avenue in Vineland, and all of a sudden, and this was a new thing I'd never seen before, thick black smoke started pouring out of the air vents into the cabin. I thought, well, that doesn't seem like a good sign, and I was choking, so I pulled over and I popped the hood to see what was going on, and when I went out and popped the hood, it went whoosh, just this huge 10 feet of flames were coming out of my car.
Is that on video?
No, so I heard this honking from behind me. Now I'm really right, because this I can definitely see too. But it was a couple that I went to church with at the time in Vineland, where we were moving. And they had a truck, and they helped me move. I couldn't get anything out of the front seat or the back seat of the car because there was like flames and melting glass and stuff, and that seemed like a bad idea. But I got all the stuff out of the trunk at least. So a couple of guitars, my tuxedo, but everything in the car was just gone, just burned away. It wasn't there anymore. And so they had a cell phone. This was like before the days when everyone had cell phones. So this car had a cell phone. So I phoned my wife, and she answered, and she said, "Hey, I'm sitting on the back porch of the place we're renting." And she said, "There's like a big fire on the highway. I can see it from here." And I said, "No, it's just off the highway. That's me. Could you come get me?" So she came and got me, and sure enough, I didn't own any clothes anymore because they'd all been in the front seat of my car, and they were all just gone. But yeah, so the next day during the wedding, we went and got pictures taken around the burned hulk of my car, and it was like a nice little send-off, or a horribly bad omen of terrible things to come.
Yeah.
Jury's out. We'll see. We'll see what happens. Anyway, so I'm hoping to avoid. But that car didn't owe me a thing either. I bought that car for $400. I got 5 good years out of it, and then 1 really bad day. I always think that we used to raise pigs at the restaurant I worked at. We raised our own animals and we slaughtered them. And I always thought they were free range. They lived in a big field and they ate really well. And so they have a really good life and then 1 really bad day. So, anyway. And I guess we're all gonna have a nice life and then, hopefully
Sir, I recommend Mrs. Orlando signs off on the insurance, so it's cheaper.
No, listen, I have a clean record, thank you. My wife, not so much.
I think that is the worst timing for your car.
There's an argument to be made that when you have loaded every single thing you own into. I'm going to say something else. I also had, because I had some cash for the wedding, so I also had $5,000 in cash in the glove box. That's fine. Listen, insurance covered everything. But imagine phoning insurance and saying, "Hey, that 18-year-old car I have insured? So it caught fire, and what was in it was everything I own and $5,000 cash." Can you imagine being the insurance agent on the other end of that call? So they have a forensics team. They went through and they took samples of fibers and things like this, and they did their investigation, whatever, and they came back, and I got a check in the mail and bought a new car and new clothes, and all was good. But there you go.
It's good for a new life, new wife.
Yeah, that's right. It was
My other wife.
it was away with the old, in with the new. Okay, so today is kind of the corollary to lesson 3.4, which we already did, which is I just want to spend a bit of time talking about. We've talked about exponential functions of this form. Today I want to look at what if I gave you the table of values. Well, I gave you a graph, but today we're going to focus on tables of values. Could we look at the data, and from those data, construct a function, make an equation? And it's actually not nearly so bad. It's, in fact, pretty easy. I think you're going to like it. So, we said, you don't necessarily have to write this because you wrote it already in your last note, but when we make a function like that, that first number, that a value, What's that? So we're going to take some number, we're going to multiply it by a number, and then we're going to do it a bunch of times. What is that first number? Yeah, it's the starting value, it's the initial value. Good job, guys. Sorry. I'm going to call it the starting value here because I already started writing that, though initial value is a much better term. So A is how much you start off with. What's B then? We take A and we multiply it by B. If anything, I would say A is the coefficient, but I guess. You could think of it. You're not wrong. That's not the term I'm looking for. Is that a fair answer? These aren't the drugs you want. So yes, we could call it that. But in terms of we take our A, we take our starting value, and then we multiply it by something. Let me ask you this. If B is really big, what's going to happen to our number after we multiply? Yeah, it's going to get bigger and bigger. And if B is really small, if it's like 1/10, very good. It'll get smaller and smaller. B is our growth rate. It tells us how we're going to change our starting value. And that's right. If you want to think of it as the growth or decay rate, because if that B is a fraction, if that B is a decimal, excuse me, this thing's going to decay. It'll get smaller. Yeah, like I said, this is me. And then I'm not. In this case, I make an addition to this that the textbook doesn't, but I said this together is how many times it grows or decays. And we put it over t because that's the growth period. So if it takes 5 years to make this happen, then we say x over 5, so that every x doesn't make a double, it takes 5x. If it was every 12 years, we'd say x over 12. So that 1x doesn't make a double, it takes 12. But in general, we have the starting value times the growth rate, and then we put it to some exponent to tell it how many times it needs to grow. Does it double once, or does it double 6 times? That's what the exponent tells us. Does that make sense? And in an exponential function, that variable, the thing that's changing, our x value, is up in the exponent. That's what changes. How many times do we let this thing double? Or if the growth rate is 3, how many times do we let this thing triple? If the growth rate's 1/2, how many times do we let this thing get cut in half? The exponent tells you how many times. So today we're going to look at creating an equation when we already have a table of values. So I didn't even make a word problem for this or anything like that. I've just made a table of values. So in this case, just looking quickly, is this going to be exponential growth or exponential decay? How do you know?
Because both x and y go up.
Very good. As x goes up, y is also going up. That's growth. That's how we grow. As time goes on, you get taller, and one day you stop growing. And towards the end of your life, you get a little bit of decay. As time goes on, you get shorter and shorter because the collagen in your spinal disc starts to degrade. You actually start to shrink. My grandfather just had back surgery, and it actually got 3 inches taller. It's weird. It's like overnight he showed up and he's like taller than me again. He's shorter than me for that. So this is exponential growth. Now, if we look at this original value, we're going to try and make an equation out of this, but I want to note something. I'm not going to worry about the growth period. You know how yesterday we had, or 2 days ago, we had x over t in the exponent, where we divided by the growth period? There's no way to know, looking at this, what the growth period is, so we're not going to worry about it. Eventually, I may get questions where in the word problem it says it's a 3-day growth period or whatever. Then we'd put that t in the equation. But if the question doesn't mention a growth period, we'll assume it takes 1. We'll just assume it takes 1 whatever x is. So we're not going to worry about the t there. So we're going to end up with something that looks like this. F at x equals a b to the x. That's the basic equation we want to get. So we only have to know 2 things, a and b. What's a again? The initial value. So we need to know how much we start with. What's b? The growth rate. So the only 2 things we need to know are how much stuff do we start with, how many x's do we, or how many y's do we start with, what's the initial y value, and then how is it growing? What is it being multiplied by? Because remember, in exponential growth, we're multiplying, right? So let's start with the easy one. What's the initial value? How'd you find that? Sorry? Yeah, and I'm going to highlight that yellow. And I'm going to make a little note up here. Actually, I'm going to make it, where will I not need to worry? Over here. The initial value is equal to 4. And we know this because it's always y when x equals 0. The initial value, just like the y-intercept on a line, was always the y value when x equals 0. The initial value is going to be, remember, x tells us how many times this is doubled, tripled, quadrupled, or cut in half, or whatever. When x is 0, how many times does it double? No times. So that's going to be how much you started with. In the second example today, I'm not going to give you that 0 on the table. We'll actually have to work backwards and figure it out. But in this example, I did. So initial value is easy. What letter do we use for initial value, by the way? A. So we can say, oh, I didn't want red. We can say A is equal to 4. We're ready to go there. Now, growth rate. Growth rate means we're taking that initial value and we're doing what to it? Very good. We're making it bigger by multiplication. And if the growth is positive, that number is going to be a big number, like 3 or 5 or 7, something bigger than 1. And if the numbers are getting smaller and smaller, that means we're multiplying by a fraction, or maybe a decimal. Good, very good. So in this case, we should be expecting to multiply by a bigger number, right? Because it's getting bigger. This is exponential growth. So remember when we were figuring out the slope of a line, you could do first differences? And you would subtract the two numbers, right? Well, we're going to do the same thing here, but instead of subtracting, what am I going to do to figure out how much bigger this got? Multiply. We're thinking constant multiplying. So I need to figure out what I multiplied by. And to figure out what I multiplied by, I have to divide. And should I divide the big one by the small one, or the small one by the big one? Yeah, I think so. So let's try that. What do we get when we divide this? 4. I would have had to multiply 4 by 4 to get 16. What if we do these two? What did I have to multiply 16 by to get 64? 4. Very good. And from 64 to 256? 4. And from here, we divide again, 4. And we should just be careful. Let's make sure that we're actually getting each step. I didn't skip any. We should, if this is the actual growth rate, that'll only be true if that's every value of x. But here, obviously, this step is a change of just 1. So we only grew 1 time, and it got 4 times bigger, right? And then we went up by 1 here, and again, 1 more doubling, or tripling, or whatever, in this case made it 4 times bigger. We grew 1 more time, and it got 4 times bigger again. We grew 1 more time, and it got 4 times bigger. So first of all, that proves to us that this is an exponential function, because it keeps getting bigger by the same product. It's being multiplied over and over again by 4. Does that make sense? Don't make it doesn't. That's half the lesson right there. So each time x increases, the growth is 4 times. Therefore, our b value must be equal to 4. So we look for when x equals 0. That tells us our initial value. In this case, it's 4. Then we have to do some dividing to figure out, as we make x bigger, by what factor is this growing. In this case, every single time we made x bigger by 1, the growth factor was 4 times. That make sense? And that tells us that our b value must be 4. So then, what is the general form of one of these functions? F at x equals ab to the exponent x. And again, because there's absolutely no information in this question to tell me what the time period is, or more to the point, we know what the time period is. What was the step to make it grow by 4? 1. So really that number there would actually be your t value. I said I wasn't going to tell you that, and I'm making it more confusing by telling you that. But whatever. How many steps you have to go up in x to make this thing happen? That's your t value. In this case, and all the cases we're going to do in this unit, it's 1. So we don't have to worry about the t value, because dividing by 1 doesn't change anything. So f at x equals a times b to the x. Now, what are our actual numbers then? So this function, f at x equals 4 times 4 to the exponent. Very good. Very good. Could we graph that? Oh, DSPN Wi-Fi is really slow today. Is anyone else finding that? You know, some days I get really good coverage. Today, not so much. Anyway, so we could say f at x is equal to 4 times 4 to the exponent x. And we get this graph right here. Hello. Okay, there we are. Actually, that wasn't well planned on my part. And what is the initial value? Yeah, I don't know why I zoomed that way out before confirming that, but can everyone see that? The initial value is 4, just like we'd expect. And we already know that by 1, it's going to be up here at 16. It matches exactly the values we have there. I think I could even have this make a table. There we go. That's the math for you. God bless that. I could put any value I wanted here and do the math for me. Yeah, it grows quickly, right? Exponential growth. Quadrupling every time. If you could find an investment that quadrupled your money every year, you could be rich really quick. By the way, you're not going to find an investment that quadruples your money every year. I had one investment once that doubled my money in 1 year. And I felt like such a grown-up for like the first time in my life. It's like, oh, I invested a little bit of money and now I have twice as little bit of money. That's great. So there we go. That is our equation. Now, the next question says, after this thing is doubled 8.5 times, how big will it be? How would we do that? Yeah, sorry, this is acting screwball-y. Okay. Yeah, we would substitute in for x 8.5, right? We would just say, I mean, they don't really make you do this a whole lot anymore, these let statements. Did you have to do that in elementary school? When I was in elementary school, every math question had to start with let x equal blah, blah, blah. And it was pretty wasted. Instead, we'd just say here, let's evaluate f at 8.5. F when x is equal to 8.5. How would I write it out? 4 times 4 to the exponent, 8.5. Great. All right, and use a calculator. Evaluate that for me. Tell me what you get. You don't have a calculator.
Well, I am a woman. What did you just say to me? He's calling me a man.
That doesn't mean man. That means unmarried woman, which, as far as I understand it, is correct. Let me know if I'm not aware of something.
Yeah, I'm actually married to Ashley Gibson. We're having a baby.
Okay.
No! Wait, what is this?
Okay, let's just make sure we get this on a calculator. What do we got? 4 times 4 to the exponent 8.5 should be a big number.
524,000.
Don't tell me the answer. I didn't
So is he fighting with me? Take it. Can I see that? Beautiful.
Is it?
Okay, so can you please make sure you can put that in and get the right number and the right answer? Is it acting screwball? Oh dear God. When in doubt, second function quit. The second function mode quits. Yeah, it always takes you back to the beginning. Beautiful. Very nice. Oh God, what are you doing? Just for curiosity, what if we stepped back in time to -2? What would f at -2 be for this function? Go ahead and evaluate that. By the way, this is maybe something I don't check in with often enough, but is everybody comfortable with function notation at this point, where you see the number in the bracket and you know that that's what you substitute in for x? It occurs to me that that might be something I just kind of take for granted, that I throw up there and never actually talk about. So let's talk. Let's talk. Is that comfortable?
Yeah.
I didn't mean you. I don't want to talk to you. Joking aside, do you get that? Okay, good. It'd be a shame if I was so busy being snarky I neglected to teach you something. That would be. One sec. God, oh God, is that yours? Because it was right in there, man.
Oh, I didn't grade.
Oh, see. You burnt. No, I don't know. Okay, how would I set this up? Before I even put in my calculator, what's it going to look like? What?
Fun numbers.
F at -2 equals fun numbers. All right. Is she right?
Yeah.
She is not. Correct.
I don't know.
All right.
I object.
Objection overruled.
5-2.
By me, I'm the judge. And jury. And if I need to be, executioner. Whom? According to whom? You need the indirect object. What do they teach you children in English? Yes, sir. Okay, perfect. And how'd you get that? What's the setup look like? Like, what did you punch into your calculator? Okay, so what did you punch into your calculator?
4 times 4 to the power -2.
Very good.
Oh.
And what did you get? 0.25? All right, did everyone get the same? C, same. Okay, good. Well done. Well done. Now, I want to look at a second example. Oh, that says, see, silly me. That should say decay. Not the bene. Not the bene. You'll sometimes see this. In fact, you'll often see this where like they put like NB and then something. I saw this like all the time, and people don't know what that means. It means note bene, which is Italian, probably Latin, but it's definitely Italian. It just means like note well. Make a good note of this. Pay attention to this. Note bene. Why don't we call you Tabitha? Because it's not your name. It's just
That's a cool name, though.
it's a great name, right? So here we go. So we're doing the same thing now. First things first.
We have no zero.
Ah, we have no zero. Oh no. What does that mean we can't find right off the hop?
We can look at
The
this.
initial.
Yeah.
See.
Yeah, we can't find the initial value yet. We don't know it. Initial value with the less common double I spelling. Hello.
Hi.
I always like to combine it. It makes me feel like there's something really going on.
Yeah,
No.
really not.
You send
Put lots of
us
stuff
the
up here.
articles instead of wandering the halls.
Tell them what to
Yeah,
do.
sir, you just have to send the article to this thing.
You were supposed to do it like 2 weeks ago.
You sure it's like this?
I still am waiting for stuff.
From
No
whom?
more waiting.
From whom? From whom?
Oh my
Come on.
god.
Oh, oh,
I'm
he's
gonna-
correcting the grammar.
Yes. From
Oh.
Yeah.
Oh.
Yeah, that's right.
He says it's too hard, but
Dude, you should know.
Math teacher. for
it's
God's
not
sake.
in period one.
Yeah.
In the lab.
Yep.
We have room for 5 kids.
Yeah, 100%.
Because there's only 5 that are going to
Totally fine. Yes, you can send them away.
Okay, that's great.
Oh,
In
yeah.
fact, to be honest, you can combine them if you want. If they want to save
That's what I mean, like,
yeah,
there
give
won't
me
be
the
another-
instructions and yeah, 100%.
yeah, this one you're working on, they don't assign it already.
Yeah, that's great.
You can just write down who was there and who wasn't.
Yeah, no, I'll do the attendance. That's fine. I don't even do my own attendance, but I'll do yours.
Sounds like good business.
I'll get on the,
Oh, yeah. There you go. Don't listen to her.
Alright, sorry for interrupting.
No, don't be sorry.
Listen to
Okay.
Rochelle. Rochelle knows all.
So the initial value,
I said listen to Rochelle. Rochelle knows all.
the initial value is not given to us. We're gonna have to go back in time and figure it out. But before we can do that, we have to figure out what the growth rate is. Because I can't figure out how much I have to grow or shrink backwards in time until we figure out the growth rate. Now, you can probably eyeball this growth rate,
Uh-huh.
right?
Think.
So let's take a look.
It divides.
As we go here and we divide, what are we going to get? 32 divided by 64 is what?
2.
No, that's incorrect. But it's the right idea. But it's not getting 2 times bigger, it's getting 2 times smaller. So that would be 1 over 2, right? That's a half. Or if you, no. For example, just hypothetical. Let's say that we agreed to a bribe. Now, I would never do that. Do that, Miss Sarge, I would never do that. But let's say hypothetically, I did agree to a bribe. Not that I would ever do that. And let's say I said, for $5,000, I will give you perfect on the final exam.
I like that.
She goes-
Only 5 grand.
She goes, okay, sure. So I take her money. And I don't like to do a lot of marking, so you should know this in advance. Your final exam's just at 2 questions. One mark for your name, 1 minute for who's the best teacher in the school, and the answers are random. 2 out of 2, 100% good. I love that. But
Encouraging us to lie.
she's already paid me off. Great. Now, having taken her money, if I then reported your mark as 1/2 out of 2, you would probably be upset. Because I think you and I can agree that 1/2 and 2 are not the same number. Because 1/2 out of 2 would be a 25% in the course, and that would be a bad mark. And you paid me for a good mark. So you just have to be careful. This is getting smaller, which means don't, with the eyes, just stop. It's scary. So, this is getting smaller, it's 1/2. Likewise, to go from 32 to 16, I would have to multiply by a half, or 0.5.
You divide the multiply.
You divide to get the number, but what I would have to do is multiply this. Sorry?
You're dividing it by a half.
I'm not, listen, stop. Give me a second. Let's go back and look up here. What did we do? We took the second number and divided it by the first number. That's what this little division sign is telling me. It's saying take the second one and divide it by the first one. Does that make sense? Tell me if it doesn't. Okay, what did you do?
I multiplied it from the top
Okay, here's the problem with that. These work nicely. So you could eyeball this and say, oh, I have to multiply that by 4, right? What if this number had been 3 and this number had been 13.725? You're not going to eyeball that, right? So you're going to have to use division again. So, like, I'm not criticizing, like, it's great. If you can eyeball the question, that's fantastic. And obviously, in the first two examples, we look at ones that we can eyeball, right? When you get to the homework, and then tomorrow when you take the homework up, you're going to get examples with nasty decimals that you have to do the division again. Does that make sense? So we always divide the second number by the first number, and it gives us what the multiplication factor is. Okay? Excellent. So, back down here, if we take 8 and divide it by 16, we will get a half. And of course, we could also write that if we prefer as 0.5. They're equally legitimate answers. And a half or 0.5. Okay, very good. Now, I know then my b value. What is my b value? Or, very good. So b equals a half or b equals 0.5. Those are both legitimate answers. Now, the problem is that I don't have an a value. So what I need to do is make one. Does that make sense? So to go from here backwards, instead of multiplying by a half, I would have had to divide by a half or times by 2. That's the same thing. But if you divide by your b, it will always move you up the scale. Does that make sense? And again, here, the number is really nice and easy. So you can just eyeball it. But when we get to ugly numbers, try it. If you divide 4 by 1/2, it should give you 8. I know it seems silly, but everyone try that. Make sure it works. 4 divided by a half should give you 8. Right? Wow, I'm sure it loves you back. I know, of course you did. And I'm not criticizing that. I'm just trying to make sure you're ready when we get to questions where you can't eyeball it, where you have to follow a bit of a process. Likewise, if you divided by a half, you'd get 16. And again, you'd get 32, and again, 64. So we eventually want to know what y is when x is equal to 0, right? That's going to be our initial value. So we have to move back a step. And if we divide 64 by our b value to work backwards, we will get 128. Sorry? Yes, and again, like, that's good. I'm not, like, it is good that you can eyeball it. I'm not criticizing that. Just make sure that you understand the process, because when you get to questions where it's a little more complicated, you want to make sure you know how to get there. Does that make sense?
For y values, decimals?
I mean, we could. No, actually. I mean, I would not even doing any graphing today, actually. I mean, I know I threw the last one on graph just to show you, but today we're going to stick to algebra. Does that make sense? Sure. You. Did I? Oh, actually, I'm pretty sure I was staring back at the Mr. Lulu thing. No, I'm pretty sure you didn't, because I can tell you the exact thought process. It went a little something like this. Does that make sense? Scotch that was. And that's actually precisely what I was thinking.
Well, I have the eyes
Of a Scotch bottle that's covered in, what do you think that's covered in? Like that tissue paper? Is that called a, yeah. Yeah, like gift wrap stuff. Is that considered lazy?
I don't think so. I've never been on a bag.
Some things make more sense in a bag, don't you think?
I never brought presents.
I love wrapping presents.
It's so fun.
When you get it, when one goes really well, and I'm not very good at it, so often they look awkward, but every once in a while you get a really good one, and it just looks super professional. No?
Well, at least I have like gloves, mittens, and stuff.
Yeah.
I don't always put those boxes in.
Yeah. I usually get a really big box and put some heavy stuff in it, and then a series of smaller boxes leading into the.
My parents did that to me.
I've done that to my kids many times.
I did that once in a while.
I was gonna do that for a Super also, and
On the bottom it says like, "Get a job, kid."
I was a bit of a jerk one time in the fact that My sister wanted a doll. My stepsister is younger. So I took the doll out of the box and then I put in something that she said she didn't want. And then I wrapped it around and then I put another box, got down, saw the box, like, no, it's not anything. And then I gave it to her behind her.
So mean.
Awful.
But so sweet at the
And
same
so
time.
I thought Lego blocks are pretty cool. And that's what I put it in.
I would want Lego blocks.
I know, right?
Lego is
Okay, so you must work backwards. Dividing by b to find y when x equals 0. That's your initial value. And in this case, our initial value worked out to be what, Mr. Dominic? 128. Very good. Again, please don't ever think like I'm never being critical. If you can eyeball a question, that is to your credit. That means you understand what's going on the page. It means you have good mathematical instincts. It means that your multiplication facts are well cemented. Those are all good things. I just want to make sure you understand the process too for when we give you questions where you couldn't conceive. Nobody knows the 32.75 times table.
Multiplication has to be done by like grade 5. You have to have basic multiplication.
In terms of what?
Like
curriculum-wise? I'm sure, yeah. I mean, I have no idea about the elementary curriculum.
because you
But-
don't like school teachers.
I like it. Oh, elementary school teachers I think are amazing. I just don't want to be one. It's like any other horrible
Oh, you
job.
have here Friday is we're trying to create like a kindergarten day.
That's every day for me. I call those weekdays. Okay, now can we turn this into a function?
Yeah.
I think we can. So f at x, so it's an exponential function. So how much do we start out with? Yeah, we start out with 128. What do we do to that 128 every growth period here? Yeah, we times it by a half. If you prefer 0.5, good on you. Nothing wrong with that. You can, but we always treat exponential functions for purposes of form as multiplication. Okay, it's not mathematically wrong to divide, but it is incorrect form. That's not the form of function we're learning. I mean, which is to say, and again, I'm not trying to be rude, you could express it as repeated addition, right? It would just be as long as, like from here to the goalposts in the field, and it wouldn't be incorrect. It just wouldn't be how we're trying to do it here. And again, I'm not trying to criticize that. The fact that you're able to intuit that that is 128 divided by 2 to the exponent x is great. Like, that's good. It's good thinking. It's correct. It's just one of those things where, like, if you learn to drive like I did in a sand pit that like your dad's friend owned, there's another step you have to follow where it's like drive on the right side of the road. There's nothing magical about driving on the right side of the road, except you just as legitimately drive on the left side of the road. That's what they do in Britain. But if you're in a country, you want to make sure everyone's driving on the same side of the road. Doesn't matter which side, just the same side. And that's how it works here. We say always treat it as multiplication just so we're all doing the same thing. Does that make sense? Ish. Okay, I can live with that. And then what goes in the exponent? X. That tells us how many times we cut it in half. So, last thing we're going to do on this note, and then I'm going to send you on your merry ways. I assume they will be merry. Is we're going to evaluate f at 12, and we're going to evaluate f at -2. Very good. So go ahead and do that. Is it? I think you should have some like where every time it's decay, you use that voice. Like preach and grumpy, and every time it's like.
How many,
Yeah, I think you should code your voices to type of question.
how many decimal places do you want?
I'm fine with just one. I'm fine with 2 significant numbers, like all the zeros and then a couple digits. But by 12, it must be pretty small, yeah? Yeah. You okay?
Yeah, that just scared me.
Oh, I'm sorry. 56, this should be 512. And what would this be? Oh gosh. Oh, sorry. That one will be 512, and this one will be, oh gosh. 100, what's 2 to the exponent of 12? God, I don't even know. What is it? 0.03. Give me a couple. Great, let's say 1, 3. Okay, there we go. 0.31. Are the digits after the 5?
No.
Oh, wait. Really? Oh, well, let's, so 3125? And that ends? Oh, we'll put that then. You can have a precise answer. That's better. So there we go. 0.03125. Good. Questions about that? Does that make sense as a process? Basically, for every one of these questions, you need to make sure you know what the initial value is, what to start off with. You need to know what the growth rate is, or the decay rate, depending on whether it's getting bigger or getting smaller. And then f of x equals a times b small x. That's it. So instead of textbook work, because I really didn't care for the order and the manner in which the textbook covers this material, I don't like the approach to this material. I'm going to give you this for homework. This is not assignment, this is just for homework. So I encourage you to do all of it, make sure you get it and get the practice. But I'm not collecting this, and I'm not going to take it up tomorrow. Tomorrow you will get assignment 3.1. Sorry? Oh, that's okay, they'll be online. They'll be online. But I knew a lot of you were away, so tomorrow during class, all we're doing is that. If you still need to finish up the Desmos work, we'll have time to do that. And then Friday will also be day, I think, possibly I'll teach a short lesson on transformations, possibly I won't. Mostly it'll be a work. Yes? That's okay.